record today and see what happens. Yee. So I thought I had it worked out pretty well, and last hour we had to change a bunch. So we'll see how it goes. I think it'll go much better this hour. So what now? 3.6, curve sketching. Curve sketching isn't anything new. It's just doing everything you've done all at the same time. That's all. So we're learning to use what we know about derivatives to sketch curves, or what we should hopefully, or what we've talked about of derivatives to sketch curves. We'll be successful when we sketch a curve using derivatives. I should drink some water too. That's probably a good plan. So the big thing to think about, what do we know so far? What do we know about functions? How do we determine those things? Well, there's a bunch of stuff we know about functions and a bunch of things we can do about them. So let's take a look. So, boom. Vertical asymptotes, when the denominator of a function is 0. If there's no denominator, there's probably not a vertical asymptote. That's pretty straightforward. But what's in parentheses is how we can determine that if you're not sure of that. Zeros, when f of x equals 0. You just set f of x equals 0 and solve, and you find the zeros of the function, aka the x-intercepts, or the roots, depending on how you want to do it. X-intercepts, again, x-intercepts are the zeros. The y-intercepts happen when when x equals 0. So you just plug in 0 for x, and boom, you've got it. That's how it works. It's nice to know if something is increasing or decreasing, and you can determine that whether f prime is positive or negative, respectively. In parentheses, that's how you determine those things. Concavity, you can determine concavity of a function now, or should be able to. And if you can, it's because f double prime is positive or f double prime is negative. That's how that looks. Derivatives. F prime and f double prime are the derivatives of the function, and we use those to do a bunch of different things, increasing, decreasing. And we haven't even got to talking about extrema yet, but that's coming up. Another thing we can use to talk about is M behaviors, and that's a lot of limits. Like we get horizontal asymptotes when the limit as x approaches in positive or negative infinity, if it approaches like an actual number. If it approaches an actual number, you've got a horizontal asymptote. You could talk about oblique asymptotes too, but we're not really focused on that part right now. If it's not a horizontal asymptote, it's going to go to a positive or negative infinity. So it's something you should think about, like what's happening there. Oh, there's Elise. Sweet. All right. Also, a point of inflection. A point of inflection is when f double prime is 0 or undefined, and f double prime changes sign there. While I'm thinking about it, I'm going to change that. And the important thing there is that f double prime changes sign. That's the issue that is the biggest thing, because sometimes you get a 0 on the second derivative, or it doesn't exist on the second derivative, but the sign doesn't change. So you got to be aware of that and just be thoughtful and look for that just in case it exists, because it could. The last thing is determining if it has an extrema. Get the critical point, which is when f prime equals 0. And I'm sure we can put that in here somewhere. I just don't think I had room. But we could put it in there. And then use the first, second derivative test to test if it's an extrema. The first derivative test says, does the sign of the function, aka f prime, does f prime change from positive to negative at that critical point? Or does it change sign at that critical point? If it does, it's an extrema, and then we can classify whether it's a maximum or a minimum from there. The second derivative test says, hey, you've got a critical point. That's fancy. Plug that x value into the second derivative. If it gives you a non-zero number, it tells you whether it's a max or a min. That's the first and second derivative test. That's what they do. And the first derivative test also tells us if things are increasing or decreasing, because we needed that piece of information in order to make that all work for us when we first did it. So we're going to use all of these to learn about a function, and then we're going to sketch that function from there. That is our goal today. So hopefully we have something that works. So let's do an example. Normally in class, I just cut you loose and say, bye, try it. And then I'd walk around and help you out with it. But that's not really the environment that we can do. So here we go. Let's try this one. F of x equals x plus 1 times x minus 2 times x minus 5. So this is really useful form because we can get the x-intercepts and the y-intercept pretty easily from this. The x-intercepts are what? -1, 2, and 5. The y-intercept, plug in 0, is 1 times -2 times -5, which is 10. Sweet. That's nice. But I also want to multiply it out because it would be easier. It's less work to find the first and second derivative this way. Boom. First and second derivative of this is much easier to work with. I mean, I can do this one. It's not hard to figure it out. It's just harder to work with. So that's always something to consider when you're trying to decide what version of the derivative you want to use, is whether it's simple or how easy it is to work with. But there's the first derivative. There's the second derivative. All right. Now we have the derivatives. Let's start in the original function. Let's start listing other things we know about this now. We know 3 zeros, -1, 2, and 5. Sweet. It also has a y-intercept at 0, 10. That's all going to be helpful. It has critical points when f prime is equal to 0. I had to use quadratic formula to make that one work because I tried factoring. I'm like, oh, that's not going to work. So there you go. Point of inflection. I really should say a possible point of inflection here because I don't really know. Let's do that. Change that while I'm thinking about it. Oh, there was just enough room. Hot damn. Let's catch back up. It's a possible point of inflection because that's when f double prime is equal to 0 or undefined or does not exist. But I mean, it's going to be a point of inflection because it's a linear function. But if it wasn't a linear function, you would still want to call it a possible point of inflection. The domain, it's a polynomial, so it's all real numbers. The range, since it's an odd function, by looking at the highest degree, the range is going to be all real numbers too. So those are both things that we should mention and to be thinking about when you sketch. What's the end behavior look like? So there it is in limit notation, and I left it up there. I left it up there for you so you can check that out. The picture is what I meant. You can see the picture about how it looks. But I also put the limit notation with, because the limit notation is a big thing that we did this year. Last year, we spent a little time talking about the end behavior like that. So that generally is telling me a lot of piece information. But now I want to determine, are those critical points maximums or minimums? Or nothing at all? Is that a point of inflection? It is. But I want to check that. Where is it increasing? Where's it decreasing? Where's this concave up? Where's it concave down? I'm going to use sign charts to display a bunch of that information. So here's a sign chart for f prime. Here's a sign chart for f double prime. So I'm going to put my critical points onto f prime, which are 2 minus square root of 3 and 2 plus square root of 3. So that's just above 0, and that's just below 4. And again, it's f prime is 0 at both of those points. Oh, that's right. So now I have 3 intervals, you see. And so I'm going to test the number in each of those intervals to see what I get. Because it's important to check, and we need to check. So let's see. Below this, 0 is below that. Let's plug in 0 to the first derivative. Where's my pointer? So I plug in 0 to this bad boy. I get 3, which is positive. Hey! Now I need a number between 2 minus square root of 3 and 2 plus square root of 3. How about 3? Or we could just pick 2 because it's right in the middle of those two. and which is going to give me 12 minus 24 plus 3. That's negative. Cool. And then a number bigger than 2 plus square root of 3. Oh, 100. So 30,000 minus 1,200. Okay, yeah, that's going to be positive. Boom. That gives us the general structure of what that looks like. We know whether it's positive or negative. We can do interpretations of that in just a moment. Now let's look at the second derivative. We have one possible point of inflection because it's 0 there. So now we want to check to see what happens before that and after that. Well, it's a number less than x equals 2, 0. Let's plug in 0 to that. Hey, it's negative. All right, sweet. That's a good sign. Now let's plug in a number bigger than 2. Say, I don't know, 75,000. Yeah, that'll be positive. Now we have these signs on the chart. Let's interpret what that means a little more. So I'm going to do some sketching that go along with them so we have kind of an idea. So it's going to increase, decrease, increase, which tells me there's a maximum at 2 minus square root of 3. And since it decreases then increases, there's a minimum at 2 plus square root of 3. It's negative here, so it's concave down up to that point. And then it's concave up afterwards. So it really is a point of inflection. Hot diggity damn. So we have pretty much all the information that we need. I'm basically going to go straight down this list and use this information to help us sketch what I think this might look like. Again, this is a sketch. This is not going to be a graph. It's going to be a sketch. Because then from a sketch, we can label the different things we know. Now, I could be even more accurate by taking the x values for the critical points and plugging those into the original function, either version of it. I chose not to do that because I just chose not to do it. All right. Zeros. -1, 2, and I should say 5, but clearly I pressed the wrong button. That's a rip. Whatever. It's supposed to be 5, and I'll change that later. I just didn't get around to it. Okay, we also have a y-intercept right up there at 0, 10. I know extrema happen on these two lines. I know the first one, I should have a maximum. The second one, I should have a minimum, right? If we went back to that previous slide, we would see that. I also know there's a point of inflection at x equals 2. So I got to remember that when I sketch this, that's going to happen. Also, there's also a 0 here, which is kind of interesting. So I have to make sure that when I sketch this, that I kind of show off that point of inflection. And end behavior. I know that it's going to start off down low and end up high. So those are things that I know. And that's using all the information. Now, we know it's going to increase until it gets to this first pink line. Yep, until it gets this first pink line. It's got to be above this point, so maybe up here. Then it's going to decrease, hit 0, change concavity, hit a minimum, and then it's going to increase, hit a 0, and just kind of keep going from there. So that is roughly what I thought should happen. Because you can see it's maybe a little more concave up here than it should be, but it's generally upside down cup. Hits that, hits a maximum. It's supposed to be right there, but I think I was off by a little bit, whatever. Goes down, hits a 0. Again, it was close. Came down, hit a minimum, hit the x-intercept, and went up from there. Boom. That's what you're doing today. You're going to spend some time working on that stuff. Again, the whole point of this lesson is to review and work on some of those concepts that we've been working on in the last 5 lessons. All right. That's what this lesson is for. And that's it. It's due soon. Very soon. Again, I know several of you are working on getting more things into me, which is fabulous. I've spent 0 time grading since that first one because I got a couple angry, not angry, but just a couple like, hey, what? I thought we had time emails. And you do. I just was on a grading binge one day and just happened to get caught up in grading things. I promise it won't happen again until it has to. I don't know. I could waste your time and just shoot the breeze for a while, or you can get off and start working on previous assignment or this assignment. It's up to you. If you want to stick around, I'll gladly answer some more questions. Otherwise, you can go and work on stuff. So if you're going to leave, have a great day, folks. If you're going to stick around and ask questions, sweet. All by myself.